like to look at several ways for calculating a confidence interval for a population mean. So here is the expression for that. So the sample mean plus and minus a value from the t-distribution times the standard error of the sample mean. We could look up a t-distribution table, get that number, find the mean, standard deviation and sample size using Excel or manually, and then evaluate this expression. Or we can lean a bit more heavily on software. So let's jump to Excel, and I've got a sample of 10 observations here. So thinking about the various things we need, the sample mean was one of them. So that's obtained using the function average. We also need the sample standard deviation. stdev.s is the function in Excel, and data in A2 to A11. Sample size is also important, so let's count A2 to A11. So there are our summary statistics: sample mean, standard deviation and sample size. Now Excel knows about the t-distribution as it does the normal, and in fact the function t.inv, INV for inverse, gives us the percentiles of the t-distribution. It needs a probability and it needs a degrees of freedom parameter. So the probability is the value, the probability below the number we want. So a confidence interval is based on at one end the 2.5 percentile of the distribution, and our theory says we have n-1 degrees of freedom. So that's the negative value, and the positive value is up to probability 97.5%. So between 2.5 and 97.5 we have that 95% probability. So again, n-1 degrees of freedom. So those two numbers are the same. Then if we jump back to the slide with the formula, this part here, the t times s divided by square root n, is the standard error, and we could evaluate that thing. So equals the t value times the sample standard deviation divided by the square root of the sample size n. Okay, so that's the margin of error. Maybe we can look at some of these things. Average, standard deviation, sample size. These are the t values, and this is the margin of error. Excel actually will do the margin of error calculation for us. The function we use for that is confidence.t, and it wants an alpha, it wants a standard deviation, and it wants a sample size. So basically the ingredients for this calculation. Alpha in this case is 1 minus the 95%, in other words 5%. The standard deviation is the sample standard deviation, and the sample size n is 10. And if we use that function, we can see that that duplicates our t times s over the square root of n, and then we can build the confidence interval as the sample mean minus the margin of error, that's the lower value, and the sample mean plus the margin of error. I think I used that one before. And then we have our confidence interval. So lower value 38.8, upper value 44.2. Based on this sample, we think it's likely that the true population mean lie between those two numbers. So a little bit of legwork, probably the quickest way would have been mean standard deviation and n, followed by confidence.t, and then the calculation. If we're lucky, we've got access to statistical software. So this is iNZight, and let me quickly show you how we'd use that. So we want to open the same file. Now I've had to save it as a CSV, basically a text format. So we can import the data, and there they are. Let me just quickly rename that variable. Don't like the look of that funny thing. So renaming. And now I'm going to select that variable here. It draws me a box plot which is reasonably symmetric and no outliers. If I select here get inference and then ignore the hypothesis testing, so select OK, then that barely blinks an eyelid and calculates the lower and upper values in the confidence interval for me quite quickly. So same numbers as in Excel, but it's done everything behind the scenes. So we have various options, a sort of manual approach that we can happily do with a calculator and a t-distribution table. Slightly more sophisticated approach where we use functions in the spreadsheet, or probably the simplest in some ways was to use statistical software to automatically calculate for us a confidence interval.